Alright guys, today I've got an exciting video. If you're learning how to mix chemicals or you have a hard time with the math, I'm here to show you how to mix chemicals correctly so that you get the right ratio for the job. So let me get into the proper gear and let's get into this. Alright, so do I look like a mad scientist? I don't really feel like it. But this is the best I got. So for chemical mixing, I got a couple different measuring cups here. It really depends on how much of the chemical you're trying to mix, but they're just cheap plastic measuring cups that I got from the store. So if I'm mixing a little bit, I can use a smaller one, whereas if I'm mixing like a big 50-ounce container, I've got this bigger one here. So it just makes it easier to measure different amounts of chemical to water ratios. So to start with chemical mixings and ratios, you have three different types. You have undiluted, lightly diluted, and then you have heavily diluted products. And we'll start here with the undiluted. So this means that the product is ready to use. You do not need to mix it with any water, and you can just throw it in a spray bottle and it's good to go. The second type of product is one that's like medium ratio. So this product is a carpet cleaner. They recommend mixing it 5 to 8 parts of water to 1 part of the chemical. So that means you put in 8 parts of water and 1 part of the chemical. Pretty straightforward stuff. The question is, how do you calculate how many ounces of the product and how many ounces of the water? And it's actually very simple. So we'll do the 5 to 1 ratio. So we have 1 part of the chemical to 5 parts of the water. Distilled, or they won't have any chemical to decay over ionized water. You want to make sure you're using distilled water or deionized water because there's going to be no contaminants in that water that are going to cause the chemical solution to degrade over time. Whereas if you use like just normal water, there's a chance that it could degrade the chemical and it wouldn't work properly when you go to use it after storing it for like a month or something like that. And you can buy like a distiller at home, or you could pick some up from the store for like $1. I think it's getting kind of expensive. Let's get in how to mix it. So we're gonna do the 5 to 1. So that means we have 5 parts of the water to 1 part of the chemicals. So you do the math, that's 6 parts total. So that means out of all of the ounces I could have, I'm just normalizing it to 6. That means if I was mixing 6 ounces of the solution, I would have 5 ounces of water to 1 ounce of the chemical carpet cleaner. So how do you convert that to different ounces, right? So we start out with 6. Let's say we're going to 50 ounces as an example. So 50 divided by 6 is 8.33. That took me a little longer than I'd like to admit. 50 over 6, just simple math. So we got 8.33, right? So if we now multiply 5 and the 1 by 8.33, we get 41 ounces of water to about 8.33 ounces of the chemical. And that gives us the total of 50 ounces. That's exactly the amount we were looking for. So whenever you're trying to figure out a ratio, you just add up the 2 parts that make up the ratio, and you take the number you want it to be and divide it by that ratio you're trying to get. So if I'm trying to go 3 ounces, then it would be 0.5, and then I would see I need 2.5 ounces of water to 0.5 ounces of chemical cleaner. So it's like a linear scaling math equation, so it's really simple to solve. That gives you the ability to really figure out any chemical ratio from there. But there are some chemicals that require really weird ratios. For this McKee's here, this can require a ratio of 1 to 256, which is the smallest, and it goes all the way up to 1 to 8. It really depends what your application is, and a chemical like this can be really hard to measure at those lower ends, especially if you're only making enough for like a 16-ounce container, and it can be hard to measure that accurately with a measuring cup. Let's say we're doing the 1 to 256, just a really hard one, and so we add the 2 up, we get 257. So let's say we want to make a 16-ounce solution of this. So then we would have to do 16 divided by 257. Once we have that, we can take that number and multiply it by the 1, which is the part of the chemical, and then we multiply it by 256, which is how much water we need. And there's going to be a drastically large amount of water compared to how much of the chemical we're using. So if I do the math, so the general amount of this you would need would be about 0.062 ounces. And if you look at this measuring cup, the lowest it really goes is maybe 1/3 of an ounce or so. 0.062, that's about 1/20th of an ounce, which is an extremely small amount. With something like a rinseless wash, I might not really consider that necessary to measure that accurately, but if I wanted to, I would need a different device, obviously, to measure. If you have something that's requiring a little bit more accuracy, then you want to get a device that can measure to that accuracy. So before we get into mixing any of the chemicals, we're going to be doing 16 ounces of this rinseless wash here. So I got my measuring cup here. Let's start with the water. Whoops. So I'm going for 16 ounces. So first of all, I'm using the wrong measuring cup. If your surface isn't flat, it might not measure that accurately. You can see I just got under 16 ounces there, which is exactly where I want to be. Whoops. I'm getting a little ahead of myself here. This is where the real challenge comes in. I'm trying to measure a 1/4 ounce with this huge gallon here. All right, sweet. So that's exactly where I want to be, about that 1/4 ounce spot. One thing that's a little sneak tip, make sure to always pour the water in first and then the cleaning solution, because if you do the cleaning solution first, when you pour the water in, it'll start foaming and bubbling, and then it might come through the top of the container. Whereas if you do the cleaner second, it's going to work its way into the water rather than being agitated with the water and foaming up. So you'll just save yourself a little bit of headache if you do it in that order. If you haven't seen it, new 360 spray head technology, guys, insane stuff. Generally, it's a good idea to kind of re-agitate it if you've let it sit for too long. So while we're here together, one thing you want to keep in mind is that if you're reusing a container, just make sure you rinse it out in between using different chemicals. Otherwise, throw a chemical in here and then pour it out, then there's still going to be some chemical left. So if you're going to reuse this container, which you're most likely going to do, just make sure to rinse it out with some water. It doesn't have to be distilled or anything. Just give it a good rinse and then try and shake it out, let it dry, and then throw in some of the next chemicals. And there you guys have it, how to mix chemicals like a mad scientist. I kind of did it poorly, but I hope you got the bigger picture here. It's mostly in the math and just being careful with when you're pouring. You know, I didn't spill too much this time, but you'll experience some spillage, seriously. This stuff can get messy. So